Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 11 to 15 of the January 2019 Algebra 2 New York Regents exam. Don't forget to subscribe to this channel for updates to the remainder of this review series. This particular installment is a detailed description as to how to solve the problems. If you need a faster explanation, just look to the description for the link to the high-speed explanation of this exam. Alright, let's take a look at question 11. In question 11, you're being assessed on how to expand binomial expressions involving imaginary terms. Question 11 reads, which expression is equivalent to quantity 2x minus I squared minus quantity 2x minus y times quantity 2x plus 3i, where I is the imaginary unit and x is a real number. Alright, before we get started, let's do a real quick review on our powers of I. Alright, so do you remember your powers of I? So the powers of I that we are going to be going over right now just basically shows you how to simplify powers of I, okay? So this is a guideline. If you have I, it's simply going to be I. But if you have a power of I that is greater than 1, it must be simplified, okay? So I squared is equal to negative 1 because I is the square root of negative 1. So I squared, the square gets rid of that square root. And then I to the third is the product of I and I squared, which is the same thing as the product of I and negative 1, which is negative I. And then I to the fourth power, you can either view it as I square, which is negative 1 square, which is 1, or I times I to the third, which is I times negative I, which is negative times negative 1. Negative of negative 1, which is just positive 1. Alright? So you just need to know the first four. Now, why do you need to know the first four? Well, this pattern repeats itself. If you want to find I to the fifth power, I to the fifth power is exactly the same thing as I because it's I times I to the fourth. And then this is I to the sixth for the same reason, I to the seventh, I to the eighth, and then the pattern continues. Okay? Alright, so with that in mind, let's go ahead and attack the problem. So we have the quantity 2x minus I squared minus 2x minus I times 2x plus 3i. Now, since there are two ways we can do this, okay? So what we can do, we can expand this completely, which will involve a lot of work, and then simplify. But there is another way that we can attack this problem that's much quicker, which is realizing the fact that the left side and the right side of this minus has common factors, okay, which is 2x minus I. So let me show that to you. So you have 2x minus I squared is basically 2x minus I and 2x minus I minus 2x minus I times 2x plus 3i. So you notice that 2x minus I, that quantity, is identical to both sides. Okay, so we can basically factor out 2x minus I. Hopefully that will simplify our expansion process. So we factor out 2x minus I is as though we're dividing by that quantity. Alrighty, so when you divide or factor out 2x minus I, this quantity and this quantity are gone. They become 1. Okay, because when you divide these two quantities, these two products by 2x minus I, this is what you have left. So you're going to have left, you bring this down, 2x minus I minus, now you have to be really careful here. You notice that there's a minus. This minus should be distributed to these two terms here. Alright, to avoid making a mistake, let me show you an intermediate step. Whenever you have a minus in front of a quantity, you want to proceed with caution. Alrighty, so now we have 2x minus I times, and now this is what I was talking about. Just bring down the 2x minus I, distribute this I to these two terms, so we have negative 2x, and this other term also becomes negative 3i. Alright, so watch out for that. Now let's simplify the quantity in the second parenthesis, the like terms that can be combined. 2x, positive 2x and minus 2x are opposites, they add up to 0. And then we can bring down 2x minus I. Now negative I and negative 3i are like terms. So negative I minus 3i, imagine that there is a 1 here, okay, like there's an imaginary 1. So minus 1 minus 3, that's basically what you're doing. If you combine those two terms, you're going to have negative 4i. Now to finish this off, we're just simply going to distribute negative 4i to these two terms here. So when we multiply that out, we're going to have let's see, 2 times 4 is 8. 8xi actually is minus negative 8xi, and then this minus times the minus in the center becomes plus 4i squared. So what did we talk about earlier concerning powers of I? We stated that if the power of I is bigger than 1, it should be reduced. Okay? So negative 8xi is good. We'll leave that alone because the power of the I is 1. But we have a problem here, ladies and gentlemen. This I has a power that's greater than 1, namely 2. So we're going to use our powers of I formula here to simplify that. I squared is negative 1, so we are going to replace I squared with negative 1. And then our final answer, if you write it in the standard form for complex numbers, it's going to be negative 4 minus 8xi. Okay, negative 4 minus 8xi. And the answer to question number 11 is option number 1. So this is how you can expand binomial expressions involving imaginary terms. Alright, let's take a look at question number 12. In this problem, we're going to be taking a look at how to calculate the probability of independent events. Question 12 reads, suppose events A and B are independent and the probability of A and B is 0.2. Which statement could be true? Alright, so before we get started, let's go ahead and review our formulas concerning the probability of independent events. We just list all of them here and then we apply them to the options and see which one generates a true statement. Okay, so probability of formulas for independent events. Okay, so first of all, probability of A and B, like what's given here, probability of A and B, if they're independent events, is simply the product of the individual probabilities. Probability of A or B is the sum of the individual probabilities, since we have independent events here. Probability of A given B is just simply probability of A. And then what do you think probability of B given A is going to be? Probability of B given A is just probability of B. And then we can also take advantage of these equations that we have here to rewrite the first equation. So probability of A and B is equal to probability of A times probability of B. But probability of A is the same thing as probability of A given B. So we can just change this as probability of A given B times probability of B. So what I did is let me show you what I did. I just took the value of probability of A, which is probability of A given B, and I just plugged it into this first equation right here. So I replaced that. So that's how I got this equation that we have right here. Alright? Okay. So it looks like we have enough equations for to solve this problem. Okay, let's go ahead and do it. So we're going to check each one, okay? We're going to check each one option that we have here, and then we'll see which one is the correct equation, which will yield a true statement. So it's basically like a check, all right? So for option 1, we have probability of A is 0.4. probability of B is 0.3, and then probability of A or B is 0.5. So, formula for probability of A or B is, okay, which one are we using? This one right here is probability of A plus probability of B. So let's see if we apply this formula to what we have. Do we have a true statement? Probability of A or B is 0.5. So is 0.5 equal to probability of A 0.4 plus 0.3? Is it? Is 0.5 equal to, you add these two, 0.7? Is it? Nope. False. So question number 1, the equation, the information in number 1 is not true. This, what we got right here, is a false statement. False is not equal. Okay? So eliminate 1. So just follow the same procedure and do the other problems. Okay, let's take a look at question number 2. So for option 2, we have to check the following. We're told that probability of A is 0.8 and probability of B is 0.25. And then the equation that we have, well, we have this too, so we can use that. And then we also know that probability of A and B is equal to 0.2. Okay, so the equation is probability of A and B is equal to what? What's the equation we're going to use? We're going to use the first one, right? It's going to be probability of A times probability of B. If we substitute this information that we're checking with here, do we have a true statement? All right, so the question is probability of, so this looks weird. This is 0.8. All right, probability of A and B is 0.2. So the question is 0.2 equal to probability of A, which is 0.8, times probability of B, which is 0.25. 0.25 is 1 over 4. So if you multiply 1/8 by 1 over 4, it is 1.8 divided by 4, which is 0.2. Or you can simply use your calculator. You will see get 0.2. Is 0.2 equal to 0.2? That is absolutely true. So option number 2 is our correct answer. Okay, so we know that the answer is option 2, but what we're going to do is we're going to show you that options 3 and 4 are false. All right? So we never know what kind of question you're going to see on the Regents exam, so we want to cover all the bases so you have a good score. All right, so for 3, we're going to check probability of A given B is 0.2 and probability of B is 0.2. And we also know that which one are we going to use? Probability of A given B, probability of B. We want to use this equation right here, okay? So we also know that probability of A and B is what? 0.2. Okay, so the formula relating all of them is probability of A and B for independent events is probability of A given B, which is the same thing as probability of A times probability of B. Okay, so if we substitute, the question is 0.2, which is probability of A and B, is it equal to probability of A given B, 0.2, times probability of B, which is 0.2. So the question is 0.2, is it equal to 0.2 times 0.2, which is 0.04? Is it? Nope, that's a false statement, which helps us to see that option number 3 is not the correct answer. Alright, let's look at number 4. How can we test that one to show that it's false? It should be false, hopefully, because we already showed that option 2 is the correct answer. So for 4, we're told that probability of A is equal to 0.15, probability of B is 0.05. So what equation relates probability of A and probability of B that we know? Well, we're also given the fact that probability of A and B is 0.2, so we're going to put that down. Probability of A and B is 0.2. All right, so let's write down the equation that relates these three values here, which is that probability of A and B is equal to probability of A times probability of B. So the question is probability of A and B is 0.2. Is it equal to probability of A, and this given information right here is 0.15, times probability of B, which is 0.05. So it's 0.2. Is it equal to? If you multiply these two together, you get 0.0075. You just multiply 5 and 15 times 5, and then you count. You get 75, and you count 4 decimal places, you get 0.05. Or you can just use your calculator. Let me show it to you real quick. So using your calculator, 0.15 times 0.05 is 0.0075. So is this statement true or false? The answer is false. This statement is false. So that clearly helps us to see that option number 4 is incorrect. So we know for a certainty that statement 2 is true. Alright, let's take a look at question 13. In question 13, we are going to use the graph of a trigonometric function to find the amplitude, period, and vertical shift with the given information. Okay? Question 13 reads, the function f of x equals a cosine bx plus c is plotted on the graph below. So we have the graph there. So the question is, what are the values of a, b, and c? All right, so we're given the function f of x is equal to a cosine bx plus c. So we want to figure out what values of a, b, and c would result in the generation of this graph right here. Okay? All right, let's start with our formulas. There's some formulas that we need to know in order to solve this problem. All right, so here are the formulas that we want to keep in mind. The formulas are to help us generate, number one, the amplitude. The amplitude of a graph, distance from the peak to the valley, is given by, distance from the center to the max or center to the mean, not peak to valley. Anyway, so the amplitude is given by the absolute value of A, all right? And then the period is given by the formula 2 pi over B. And then your vertical shift is simply the C value. Alright, so this is more than enough to help us solve the problem. Let's start by determining what A is. Alright, so we need to find what the amplitude of this graph is. So amplitude is the distance from the central position to the max or the mean. Okay, so if you look at this graph, it goes between 5 and 1, right? 1 to 5. So if you find the middle point, 1, 2, 3, 4, divide 4 by 2, you see that this is the center. This line divides the graph into identical halves, all right? So that's the central point right there. So that's your new x-axis. You can call that x new. After the shift, x new. And then what's your y-axis going to be? If you look at this cosine function, we know what the cosine functions look like. So we can easily see that the new y-axis is the same thing as the old one. So there's no change. There is no horizontal shift, just a vertical shift. Okay, so hopefully you can see the shift right here. Let me show you what the original cosine graph looks like. The original cosine graph should look something like this. So from here it goes like that, and then down to the bottom. Okay, and then it just goes on. But what happened is that the graph got shifted. It got shifted 2 units up. So this old origin went up 1, 2, actually it's 3 units. It went up 1, 2, 3, and then the peak, you see this peak right here, went up 1, 2, 3. So it got shifted up by a value of 3 units. Okay, so this is our new function. The reason why we want to know where the center is because the center helps us to determine where the maximum and the minimum are. Okay? Alright, so let me show you the max and the min. So the maximum is a point that goes through all the peaks right there. So that's your maximum. And this is your minimum right here. Bam. Alright, so the distance from the center to the max or min basically represents your amplitude. Okay, alright, so from here to here, this is your maximum. Oopsie. This is our maximum, max, and this is our min. So if you want to find what the amplitude is, all you just look for is the distance between the maximum and the minimum. What's the separation? So if you count it, it's 1, 2. So your amplitude is going to be 2. So the absolute value of A is going to be 2. Okay? Now, is A going to, so basically A is going to be plus or minus 2. How do we know what A is if it's plus or minus 2? In order to figure that out, we need to go back to the configuration or orientation of our cosine functions. Okay, so the positive cosine function starts from the maximum and goes down. It's just like a cup. All right, so this is y equals a cosine x. But if it starts from the valley, the minimum, and goes up like an inverted cup, then this one is going to be y equals negative a cosine x. Alright, so since at the x-axis it starts from the maximum and goes down, that automatically tells us that a is positive. So in this particular problem, a is going to be positive 2. You don't need to bother yourself too much about the sign of a because the only options that are presented here are both positives. Alright, so we don't have to bother about the sign. We automatically know that a is 2 based on the options, but also thinking about the orientation of your cosine graph, you can automatically determine what the sign of a is. Alright, so we can eliminate 3 and 4 since they have the wrong a values. The next thing that can help us figure out the answer is the b value. Alright, the b value is related to the period. So the period is what? What is the period? The period is basically the distance between consecutive maximums or consecutive minimums. It doesn't matter, the same thing. So this is I'm sorry, consecutive, yeah, maximums or peaks. So this is one peak, this is another peak right here. So the distance from this peak to this peak, since you're next to each other, that, ladies and gentlemen, is your period. Let me switch colors here. This is our period. Alrighty, so the period in this graph, let's count it. 1, 2, 3, 4. The period is, count again. 1, 2, 3, 4 is 4. Alright, so the period is 4. Now, oh, quick correction. The period is not 4. The period is pi over 3. Okay, counting my units. So if you look at the calibration of our x-axis, 1, 2, 3, 4, 4 tick marks is equivalent to pi over 3. Alright, so the period in this problem is pi over 3. Alright, that looks better now. Okay, so we know what our period is, pi over 3. So we can use that to find the b value. So let's rewrite the equation that we talked about earlier. The period is 2 pi over b. Alright, so the period in this problem is pi over 3. So pi over 3 is equal to 2 pi over b. Now we're going to solve this problem for b. Alrighty, so to do that, we are going to multiply both sides by b. If we do that step, it's going to cancel this b out from the right side, and we will have b, or pi over 3b, equals 2 pi. To finish this off, we'll simply multiply both sides by the reciprocal of the coefficient of b. So the reciprocal of pi over 3 is 3 over pi. You can divide both sides by pi over 3 also, but that looks weird and complicated. So I'll use a simpler option, which is to multiply by the reciprocal of the coefficient, an equivalent step to dividing by that coefficient. Alrighty? So this pi cancels out with that. This 3 cancels, which is what we desire with this 3. And then we have b equals, and then on the right side, the pi's cancel out. Cancel. And our b value is 2 times 3, which is 6. b is 6. So we can clearly see that the answer to question 13 is option number 1. And just for confirmation, remember we talked about the shift. This is the x old right here. Alright, if you want to calculate what the vertical shift is, you just ask yourself how many units from the old x-axis to the new x-axis. So it's 1, 2, 3. Bam. So it's 3 units up. So that automatically tells us that C is 3. That confirms that the answer to question 13 is option number 1. Alright, let's take a look at question 14. In question 14, we're looking at how to generate equations of a parabola given the focus and directrix. Question 14 reads, which equation represents the equation of the parabola with focus negative 3, 3 and directrix y equals negative 7? So a tip I'd like to give you on a problem like this is if you're given just the focus on the directrix and you have to find the equation, you want to use a sketch to find out your values. Okay, so always use a sketch to visualize the placement of values. Placement of values and orientation. Okay, so if you don't have a sketch, it's very hard to do it. It's not impossible, but it's easier when you have a sketch. Okay, so we're dealing with a parabola right here. So the question is, where does the parabola open towards? We know the parabola opens towards the focus, right? And then the directrix is on the other side. So what are we talking about? Is it to the left, to the right? Is it up or down? It's hard to determine those values without a sketch. So what we're going to do is give ourselves a visual of what's going on here, and then it's going to be really easy to figure this out. So let's see. What is the opening of our parabola? That would tell us if it's going to be y equals 2 or x equal to. If you look at the options that we have right here, it automatically tells us it's going to be y equal to. So it's going to be an up or down orientation in the direction of the y-axis. Now, let's sketch the focus first. Negative 3, 3. So 1, 2, 3, and then go down. I'll go up. Sorry, go up 1, 2, 3. Bam, right there. So that's the focus of our parabola, and then the directrix is located on the line y equals 7. So it's going to be up here. Looks like I'm going to run out of space, so let me do it again. So 1, 2, 3, and then go up 1, 2, 3. So that goes the focus, and then the directrix. So this is 3 right here. Is that line is y equals 7. So 3, 4, 5, 6, 7. Bam, right there is the directrix. So with these 2 points, can we figure out what the parabola looks like? Well, let's join the directrix first. Okay, the directrix is the same distance from the vertex as the focus is to the vertex, and is on the opposite side. It's outside the parabola. Okay, remember that the focus of a parabola is always inside the parabola. The parabola always bends in the direction of the focus. Now, where are we going to place our parabola in this situation? where is the vertex going to be? The vertex is going to be right down in the center between 7 and 3. Okay? So to find a median, all you just do is subtract the 2. 7 minus 3 divided by 2. So 7 minus 3 is 4 over 2, which is 2. What we just found is the p-value. Okay? So the p-value that we're going to be using to generate the equation of our parabola is 2. So the p-value is basically the directrix, the x value for the directrix minus the y value for the directrix minus the y value for the focus over 2. Alright, so it's 4 over 2. Alright, this is one way of finding that p-value. Another way of finding that p-value that helps us locate our vertex is just count. 1, 2, 3, 4. What's at the center? This is at the center right here. So it's going to be that 5. See that 5 right there? That's right at the center. So do you see what the parabola looks like? We're going to fold the parabola in the direction of the focus. That's how it behaves. So it goes right here. It goes down like this. Down. Excellent. So this right here is P. Remember, P is the distance from the directrix to the vertex and is also equal to the distance from the focus to the vertex. They both have a value of 2. Okay, now to finish this problem off, we need the formula for the parabola with this kind of orientation. So the formula for parabola opening up and down is y equals 1 over 4p times x minus h square plus k. Okay, so what is hk? Hk, you just look at the vertex of the parabola. Alright, so this is the vertex right here. Let me show that to you. This point right here is the vertex. So the vertex is what? The y coordinate is 5, the x coordinate is 1 to 3. So the vertex is 3, negative 3, comma 5. Alrighty? So we just need the vertex h and we need the vertex and p, and we're good to go. So the vertex is negative 3, comma 5. Alright. So if we put it into the equation, so this is h and this is k. So h is negative 3, k is 5. What is p? We already found p, right? P is 2. So we plug all that into this equation. Oh, and also, in this particular case, is our parabola happy or sad? Because this is plus or minus, right? So let's be careful with that, or else we could mess up the problem. So it's plus or minus. Plus or minus. If the parabola opens down, then it's going to be a sad case. Okay? So if it opens down, just as in this case, since it opens down, what does that tell us? The sign is going to be negative. So y is going to be negative 1 over 4p times x minus h squared plus k. Okay, so I hope that makes sense. Opening down just looks like you're sad, kind of, sort of, but so open down is negative, and then it opens up is positive. All right. Okay, so this one opens down, so our p is going to be negative here. So our answer, we're going to put everything together now, is going to be y equals negative 1 over 4p, which is 2, times x minus h, so minus negative 3, square plus k, which is 5. Alright, I just took these three values and I put it in here. So let's make it look pretty. Final answer is y equals negative 1 over 8 times x plus, so minus minus is plus, plus 3, quantity square plus 5. And the answer to number 14 is option number 1. Oh wait, hold on. This doesn't have a minus. We need a minus and a plus. Okay. Alright, yeah, option number 3 is the answer. let's make sure. So minus 1 over 8, x plus 3 squared plus 5. Okay, so there you have it. All right, let's take a look at question 15. In question 15, we're going to be assessed on how to solve rational equations. Okay? All right, so the question reads, what is the solution set of the equation 2 over 3x plus 1 equals 1 over x minus 6x over 3x minus 1? Now, a tip to keep in mind concerning solving rational equations, very, very helpful tip, is the first step, which um, makes it really easy. All right, so the first step is to eliminate the denominator by multiplying by the LCD. Okay, start by eliminating the denominator or denominators, all of them. You want them all gone. Okay, denominators by multiplying by the LCD. That then simplifies the problem considerably. All right, so to illustrate, check this out. We have 2 over 3x plus 1 equals 1 over x minus 6 over 3x plus 1. So the goal is to eliminate the denominators, 3x plus 1, x, and 3x plus 1. To accomplish that, we have to find the LCD of the denominator. So the LCD of 3x plus 1 and x is the binomial expression that these two can go into evenly. So since there are no common factors, it's simply going to be x times 3x plus 1. Okay? Alright, if you do not know what the LCD is, just simply take all the denominator factors, put them next to each other, and multiply. It's going to be a little bit longer, but you will get the same answer. Alright? So to eliminate the denominator, what I'm going to do is multiply every single term by the LCD. So let me rewrite this again, 3x plus 1, so that you can see exactly what's happening. Alright, so multiplying by the LCD, the first one we're going to multiply by x times 3x plus 1, and then the next one x times 3x plus 1, and then the next one times x times 3x plus 1. Alright, and then let's simplify. Check this out, this is really cool. Now in the first term, the 3x plus 1 and the 3x plus 1 divide out. That denominator is gone. And then here the x and the x divide out. And then here 3x and 3x divide out. This shouldn't surprise you. This is what the LCD is all about. It's a common divisor. Okay, all of them can go into the LCD. That's why we chose to multiply by the LCD, so they all go away. All right, and we are left with 2x equals 3x plus 1. Oh snap, we have a minus here. So what does that mean? Because of the presence of this minus, we want to proceed with caution. Alright, so we just multiply this minus and then the x right here. So we have, okay, just a small correction here. There is an x in the problem, so there's a 6x right here. So let's bring it down. Okay, so there's an x. Alright, so when we multiply them together, 6x times x is going to be negative 6x squared. Alright, so now if you take a look at what we have, the problem that we have compared to the original, this looks much nicer, right? This is just a quadratic trinomial equation when placed in standard form, and this is a complicated rational equation. So what we're going to do is place it in standard form. Terms in descending order of degrees equal to 0. Alrighty, so we'll add 6x squared to both sides, so we have 6x squared, and then plus 2x, subtract 3x from both sides, and then subtract 1 from both sides, set it equal to 0. I'll go here to place it in standard form, alright? So these two terms are like terms, so we are going to combine it, and then we have 6x squared minus x minus 1 equals 0. And then we're going to solve this by grouping, alright? So let's go ahead and play the x game here. So AC, let me see. You have A, B, C. A is 6, B is -1, and C is -1. So AC goes on top. AC is -6, and B is -1. So what two numbers multiply to give you -6 and add to give you -1? -3 and 2. Okay? Alrighty. So let's put it in and finish this off by factoring by grouping. So we have, what do we have? We have 6x squared. Take out the middle term and replace it with -3x plus 2x. These are the two values we got from the x game. Okay, put in the center, -1 equals 0. And then break it down the center, and we're going to factor by grouping. All right. Okay, from the first two, the GCF is the greatest common factor is 6 and 3, 3. X squared and x to the first power is x, so factor that out. So what are we left with? 3x squared, if you divide this by 3x squared, by 3x, you have 2x minus 1. Bring down the plus. Nothing goes into these two, so just pull out 1, and you have 2x minus 1. Pause and check to make sure you're doing it correctly, and that's the case here. These two quantities are identical, so that means we're looking good. Alright, so let's factor out the identical quantities, which is 2x minus 1 and 2x minus 1. Factor that out, and then you have 2x minus 1. And what's left out is the coefficients of that quantity 2x minus 1. Those two are grouped together in their own nice little parentheses. Alright, so to finish this off, we're going to use the zero product property, or the ZPP. Alright, 2x minus 1 equals 0. Send both factors to 0, and then you solve. For the first one, you can add 1 to both sides. You have 2x equals 1, divide by 2. And then you have x equals 1/2 as the first solution. And then this one, subtract 1. You have 3x equals -1, divide by 3. And you have x equals -1/3. Alright, so our solutions for this problem are what? What are our solutions? Our solutions in set roster notation are 1/2 and -1/3, right? Wrong. Now, whenever you're solving rational equations like this, because we multiplied by the LCD, we might have introduced extraneous solutions. So in order to make sure that we do not create any extraneous solutions, we have to look at our restrictions on the x value. So the restrictions on the x value just involve setting the denominator equal to 0, the LCD equal to 0, and making sure that we do not come up with any of these answers. So there are restrictions. These restrictions ensure that our denominator does not attain a 0 value, which results in the equation being undefined. Alright, so we had x times 3x plus 1. So you just set both denominator factors to 0. So x cannot be 0, and 3x, okay, x cannot be 0, and 3x plus 1 cannot be 0 also. If 3x plus 1 cannot be 0, that automatically tells us that subtract 1 from both sides. 3x equals -1, divide by 3. That tells us that x cannot be -1/3. Uh-oh, we have a problem, ladies and gentlemen. This answer, -1/3, is extraneous. Alright? So even though it shows up in the solution set, it does not satisfy the restrictions. So the actual solution to this problem is just 1/2, and that's it. Alright, so the answer to question number 15, to question 15 is option number 3. Alright, so this is basically how you solve rational equations. Thanks so much for taking the time to watch this presentation. Let us know what you think. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or requests, just post it in the comment section below and we'll be more than glad to assist. Don't forget to subscribe to our channel for updates to the remainder of this review series. More support resources can be found at mathgotserved.com under New York Regents. Thanks again for watching and have a wonderful day. Goodbye.